let's go over number 25 of the SOA release questions for exam P. So, as always, let's start off by reading out the question. A blood test indicates the presence of a particular disease 95% of the time when the disease is actually present. The same test indicates the presence of the disease 0.5% of the time when the disease is not present. 1% of the population actually has the disease. Calculate the probability that a person has the disease given that the test indicates the presence of the disease. So there's two scenarios essentially in the denominator, because so the denominator is going to be the given portion, and so the denominator means that as long as the test shows that it is positive or shows that the person has the disease, that's going to be the denominator. The numerator is going to be when that person actually has the disease and is also showing a positive test result. So let's create two equations. So the probability that the test is positive given that they have the disease, and that's going to be simply 95%, so 0.95 times 0.01, and that's going to equal to 0.0095, and the other portion of when the test is actually positive is when the person does not have the disease, but the test is still showing positive. So the probability that the test is positive given that they do not have the disease. So I'm going to annotate it with a C, indicating that's the complement. All right, so we're gonna do this as 0.005 for the 0.5% of the time when the disease is not present, times the rest of the population, which is 99% of the population does not have the disease. And so 0.99 times 0.005 is equal to 0.0, whoops, that's an ugly zero, 0.00495. Okay, so now we have our two probabilities, our two discrete probabilities. So the probability that a person has the disease given that the test indicates the presence of the disease. So we're going to take the 0.095, 0.0095, and divide it by 0.0095 plus 0.00495, and that's going to equal to plus that 0.65744, and that's going to be our answer choice B. And this was a pretty simple question, so hopefully everyone's used to Bayes' theorems questions at this point. All right, if you have any questions, leave it in the comments. If you want to see more of these videos, leave a like and let me know what you think. All right, catch you guys in the next one. See ya.